Hi, and thank you so much for joining us. We have a very, very interesting software supply chain attack to talk about today. Bots that are actually being used to steal passwords, and you can probably guess for yourselves what those passwords are being used for after that. But first, let me introduce my guests. I have with me Joseph, who is a very well-known contributor to open source, and he's so well known that he's one of the 1% or top 1% ranked on Stack Overflow. That takes a lot of doing. Joseph and his team are hunting for software supply chain attackers, thereby helping keep the ecosystem safe. Hi, Joseph. How are you?
Thank you very much, Barak. Hi. Exciting to be
I
here.
also, I'm very happy. We're happy to have you with us. I also have with us Danny, who's a cybersecurity expert who also happens to be an author. There's not a lot of those. Well, not authors that are not directly related to what they do. He wrote a book called 1001 Cyber Tales, currently only in Hebrew, but we're working on the English translation. Danny co-founded Scribe Security, a company focused on evidence-based policy enforcement. I know it sounds complicated, but bear with us. Before that, he led the cybersecurity defense research branch of the IDF. All in all I'm saying is it's obvious that Danny knows what he's talking about when it comes to cybersecurity and defense. Hi, Danny. Lovely to have you with us. Danny, are you there? Or are you muted? I
Yeah,
think you're
Muted.
muted.
I'm here.
Okay,
Sorry. Thank you very much, Barak.
it's okay. So before, without going too far abroad, let's dive right in by asking Joseph, how do you, because you're the guy who discovered this attack, how do you describe software supply chain? And directly, how do you describe a software supply chain attack?
That's an interesting question, and I have an illustration to answer it. So there are multiple great answers. It depends on your perspective. So uh, I'm sharing my screen. One moment, it's going to appear. So basically, software supply chain is a process. So we have a beginning and we have an end. We have the developers, the software engineers. They produce the software, they write the code, they decide what components they want inside, like dependencies or code snippets from the internet. At the end of this process, it's getting to some kind of consumer. It can be fed into another software component as as a dependency. It can be used by and end customers and end users, like it's a desktop application or service. But when we look at this entire process, it builds off all kind of links. So if we look at it from high level perspective, we have developers contributing code into source control. It's then being built in all kind of build servers, CI/CD servers, collecting source code, compiling them with dependencies, producing an artifact. This artifact might be parked at CDNs or organizational artifact server, and then going to be delivered to the consumer. So it's go through all kind of of steps until it's being produced. Um, and if you look on each and every one of these potential places of this process, let's imagine a chain, and in each one of them
Mhm.
is a link. So if an attacker compromises, for instance, like the developer's credentials, we're going to talk about one example in a couple of minutes. So it potentially can contribute malicious code, harmful code, make all kind of modifications um, directly for to the source code, and then it's poisoned. Just an example. So this diagram and this like let's say common language was done by Salsa. It's a
Mhm.
framework initially contributed by the Linux Foundation. It's now, it's a big thing. I'm sure all of the participants heard of it. So this is a process. In my perspective, if you ask me, how do I describe a software supply chain? It's a process, and we need to secure it. This is
Okay,
my perspective.
so just to sum it up, the supply chain, as in the chain of it, is everything we see on the screen. Each part that is written is one of the bases and the links are between them. And an attack is anything that disturbs any of these things, either the bits themselves or the links between them. So any disturbance to any of those things is a software supply chain attack, right?
Yep.
If I may add,
Yes.
just a bit this drawing that you put on is could be misleading, and I think we all understand that actual software supply chains are extremely complicated. Like an enterprise would have multiple source controls and multiple languages and multiple package repositories you consume from and multiple build pipelines, and all this is written by people, which makes it much more complicated.
Yeah, I agree.
People,
Totally agree.
yeah, people are always the weakest link in whatever it is we're building. That's why there's so many phishing attacks that work. Because you mentioned that an essential part of that process is the developer and obviously the source code, we're going to be talking about a repository attack, like you said later on. What's the difference to you between vulnerable code and malicious code? And should vulnerable code and malicious code be handled the same way?
So that's a very interesting topic. Uh, so w- I started to deep dive into this field over 3 years ago. When I started together with my co-founder, we founded a startup company called Dustico, and we basically tried to solve this exact point. There was a gap of the market understanding of the difference between vulnerable code and malicious code. So when we started, it was before the SolarWinds incident and what makes the market think different. Uh, when you have vulnerabilities in your code, it usually contributed by developers unintentionally. So they made a mistake like buffer overflow, SQL injection, etc. But they didn't they didn't wish for that to happen at the end. So whenever we find and the community finds vulnerability, it's done after we release something to the air. It can be in an open source project, it can be in internal projects, and and this is something that people make mistakes. People make this kind of vulnerabilities. So this is for vulnerabilities. On the other hand, when attackers contribute malicious code, most likely they will not have any bugs or buffer overflows. They'll test it before they ship it. Uh, and when this happens, you can't mitigate it. It's an incident. It's not something that you can. When you compare it to vulnerability, you can. Maybe it's not applicable for my solution. Maybe I'm using some library with critical vulnerability, but that specific path for the exploitable area of code in that dependency is not relevant for me because I'm not using the vulnerable functionality. That can be considered when you're handling vulnerabilities, but it shouldn't be a discussion when you're handling a malicious, packages incidents. That should be treated differently. You had an attacker inside of your organization. You might be compromised. It's an incident you need to understand very well. So that's a different mindset when you're handling this.
That's an important distinction, and I'm glad we covered it. It's not a secret that everybody uses open source. I think that one of the numbers I heard, and I have no way of guaranteeing or verifying if it's true, that about 80% of all products are comprised mostly of open source, as in a whole bunch of open source and a couple of stuff built and connecting it on top. Should we or can we actually trust code from, well, essentially strangers, even if it's open? That means we can look at it, but do we actually have the time to look at all this code?
Uh, so everyone uses open source.
Mhm.
So basically, it makes a lot of organizations progress rapidly. Developers are not creating common building blocks from scratch. It has a lot of benefits. But what developers are asking for, let's say a specific package, comes with side effects. they come with another transitive dependencies. This
Mhm.
is like a simple example. This is what might happen when you use a single package. You'll get a forest of transitive dependencies. So for your question, can you trust it? Let's say I'm a very responsible software engineer. I would like to review each and every piece of code I'm getting from this example dependency, CNCJS. I'd like to review the contributors. I'd like to review, what code is contained inside to just make sure it's not A, vulnerable or create, vulnerabilities to my application, or B, contain malicious code to, steal some critical information from my organization. If I would like to go into the process of reviewing that, I would invest a lot of time because this single package delivers over 800 different transitive dependencies contributed by over 600 different contributors, to do like credit score for each and every one of them, and to make sure all of the transitive packages are valid and okay and, up to date and not containing malicious code. It would take me a lot of time. Some may say I would better off writing this piece of software by myself instead of doing this code reviewing. This is just one perspective. So let's take an example. When I started, I advised with the senior developers, and I asked. This is two open source packages. One is with this kind of amount of stars and likes and downloads, and the other one is not, but it looks very relevant. I was told use the more popular one, use the more common one. It probably would bring you to a safe place. So I'd like to give you an example of a great guy called Faisal Salman. He's living in Indonesia, and he's responsible for a very popular package, NPM package called UA Parser JS. It's a compact library to parse user agent strings from the browser string, saying the operating system and the browser type and the version, etc. So if you're building an application, need to parse this kind of information, this is the go-to library. So it maintained for many years, quite popular. And 2 years ago, this happened. We saw this message on a Russian hacking forum. Some hacker said, I'm selling a development account on npm.js with a couple of millions installations every week. And he started like kind of a bidding, $10,000 first bid, and then each step is $1,000, like a game. Eventually, a couple of weeks later, Faisal posted this message. He said he's sorry, someone hacked his account, published multiple malicious versions directly to NPM. Those versions preserved the original code, but contained a pre-installation statement. So whenever a victim just updates the package, it immediately gets a crypto miner and a software to steal the credentials stored on this environment. So can you trust software even if it's open? Especially, if I heard some myths. Go with the popular ones. They're probably safer. No, even popular open source can deliver malware. They can bring you to the point of being a victim, and it's that easy to A, to attack, and B, to get this kind of malicious code.
Well, that definitely sounds scary. You didn't, though, say, okay, so what is the right process to handle open source? But that's why we have Danny for later. Danny, you can start thinking now. I know that's not an easy answer. Okay, so let's come to the main event, the discovery which you made, which basically prompted me to go to you and ask you to be a guest here. About a month or a month and a half ago, you published an article which describes a very interesting attack, and it was interesting to me because it makes a lot of sense to attack in this way. It would go under the radar of most people. So, could you explain exactly what you discovered and what potentially were the results? I'm saying potentially because I don't want to assume that anybody who was attacked, then later did nothing, and all their passwords were stolen. I would like to presume that at least some of them did something after that, but let's assume they did nothing and everything went bad, and what could happen?
Sure. So I'll give a bit of a background of Dependabot. Let me reshare my screen. Let's click on present. Yeah. Okay. So Dependabot is now for I think a couple of years is an official offering from GitHub. Dependabot is basically offering a free out-of-the-box solution to keep your dependencies up to date whenever a new vulnerability comes out and you have a fix. So this bot offers you a pull request. This is one example from the Flask project. This is a pull request opened automatically by Dependabot, offering the project maintainers to update this dependency with all of the context inside, so they can decide, yes, we'll go for it, no, we don't merge it. So in this case, they merged it, and this is how it appears on the right side of my screen on the history of the actions done on this project. This is the commit history log. So you see Dependabot making some commits, bumping something to something from version this to version that, etc. This is a very common thing to see in open source project because it's an offering provided for free, and if you're a responsible maintainer, you will accept these kind of offerings. So this is Dependabot. It's a great bot. It's a great offering from GitHub. Kudos to GitHub. What happened is, while we researched and explored all kind of anomalies across the internet, my team is hunting for attackers all across the different ecosystems, this is something we bumped into. We saw this user called Dependabot, exactly as Dependabot is making commits. We saw this kind of bizarre commits on random projects across the internet. So we saw a fix, and this was the user account. And when we looked inside, we saw it contributed malicious GitHub action. This GitHub action is exfiltrating the project secrets, environment variables into this endpoint, this C2 server. And in addition, every JavaScript file on that project is also being infected at the end of the file, padded with this obfuscated import statement, which basically loads another piece of code from that exact server to impact web applications.
Mm-hmm.
Now, we contacted all kind of victims using cold emails. We send them, hey, user account. We send multiple of those emails. We said, we noticed that your GitHub account added a malicious GitHub action. We initially thought this was kind of an experiment, maybe by security researchers. We described what we saw. We gave links, and we just asked multiple of potentially victims we saw, because the email address is public when you look at the logs. We asked if it was done by purpose or it's something new to them. And we got a reply from a couple of victims, and we jumped on a call, and we immediately started to try to help understand and also to get some clues. They shared a screen, and we went over the activity log, and what we found out that after ping pong and escalating it into GitHub support, because not all users have access to the full audit logs. Like if you have a personal access token, which many developers create to define and bootstrap their development environment, it's not something that you see its activity done appear in the log. You need to ask GitHub for that, unless you're an enterprise account. So we asked him to contact GitHub support, and we had a thought that maybe some threat actor exfiltrated with maybe a malicious package, maybe it's a leaked secret somewhere. We suspected that it was exfiltrated and misused, and we were right. This is the victim messaging us with a reply with the full log, and we basically confirmed that inside we saw the activity, exactly what token was misused. At the end, he rolled these tokens, but the attack happened this way. Threat actor got access to multiple victims' personal access tokens. These tokens grant access to all private and public projects as you logged in as the developer. The attacker most likely automatically contributed malicious code into multiple projects with right permissions related to the developers, the victims. As you saw, they added the malicious GitHub action, sending it to this C2 server. And also for web applications, they poisoned the source code, so any web user filling up username, password, login forms is also, the malicious JavaScript code is also exfiltrating those credentials for the edge users to that C2 server. So this is, in a nutshell, this is what we saw. We contacted multiple victims, and I think it's one of the first time we saw, attack going under the radar, mainly because the attackers use a technique for faking the Git commits to appear in the Git log as it was done by Dependabot, which is well-known and legitimate activity you see on your Git history.
So my next question is very much related. Could anyone have perpetrated this attack, or do you need special skills or special access to be able to do it?
You need some skills. I mean, it's not hard to acquire them. We wrote a couple of blog posts on, from an attacker's point of view, on how we see attackers, or how easy it is to fake commits. Like, I can claim that all kind of popular entities, like the Linus Torvalds or other popular contributors are part of my open source software very easily, because I can fake their contributions. The Git structure is very simple. You need a user account, you need an email, you don't need to log in with this, you need just to claim that those users contributed to your project, and you can easily fake those. And this is one technique the attackers used, not that difficult. And we think and we suspect it was also involved with harvesting those personal access tokens. Maybe malicious packages, maybe another kind of attack, but it was quite advanced. It's not that complicated.
So advanced but not complicated. So we're not looking at state-sponsored.
No, it's
big
not nation
group
state
with lots of money. Even one or two people from their mom's basement can basically do all this thing, and then have a nice big fat package of a bunch of tokens and passwords, and also possibly users and passwords from the internet to offer for sale.
Well, we don't know what they did with all of the stolen information. We know where it sent to. We alerted the victims. Maybe this kind of scam is involving with stealing money, stealing cryptocurrency, maybe doing another multi-step attack to steal and to ask for ransom for the source code. This is all like estimations. We do know that this C2 server is presenting a front-end application to appear legitimate, which is obviously not. The infrastructure was set up to look legitimate. Both the contributions on the Git history and what you see when it was up, when you open this address in your browser, you would think this is a legitimate software service offering. If I remember correctly, it was something related to WhatsApp.
a good way to hide under the radar. So one of the reasons I wanted Danny to join us is because I consider him one of the best defense cybersecurity experts I know. So Danny, now that you heard this attack and knowing what we know now, how would you suggest people in general, not specifically that particular one, but in general, how would you suggest people would defend themselves against such a thing?
So, the answer is already written in many frameworks. And I think the challenge is basically deploying these ideas and getting them work easily. I would say here, focus on three aspects. First is access control. And in this case, the stolen tokens are a means to gain access. And many platforms allow the administrator to know which tokens were created, when they should expire, to expire them. In GitHub, the situation is a bit different because in GitHub, the token is a personal entity. You would need to ask the programmer to check his credentials. But in many other platforms that are very popular in enterprise situations, these things could be automated, and an enterprise could decide on short-lived tokens, like, I don't know, every once to switch the token. So this would limit the access. Suppose someone stole the credential, it would limit the access time, which would limit the damage. So that would be the first, as limiting access. Another way of limiting access is on the source control platforms requiring reviews, pull request reviews, and actually doing these reviews. The problem with these the Dependabot is that the basic intuition is to press approve, because we know it's Dependabot from GitHub, and that's the whole trick here. But even a quick glance to see that I think that every programmer would understand that changing the sources themselves is not something that Dependabot is supposed to do. The dependencies usually reside in some special file, like the requirements.txt in Python or the package.json in Node. So anything that is done out of these out of this scope should be suspicious. And third is signing commits, even though I'm not sure it would help in this specific situation, because, but signing commits is another way of limiting access to the code. And in this case, forging the commits would be harder.
Well, that's definitely a very comprehensive list. Apart from the one about asking people to check everything, I know people, I am people, and checking everything is something that you don't always have the time or the energy to do. You're always rushed. We all know people, so I guess that's exactly why they did it with Dependabot. Because being aware. Yeah.
So these things can be automated, and like we could devise a simple policy and say the identity Dependabot deduced only by the name in the commit, which that is not reliable, okay? But using that name and have a policy that's saying that Dependabot is not supposed to touch .j. That could be a policy that could be deployed with depending on the tools you choose, and we could move this burden from the programmers.
Which I'm sure a lot of people listening now would say, now that is a good idea. So I started saying that because being aware of the problem is definitely one of the first steps in dealing with it. How aware do you think the security community is of such attacks? Not just this particular one, but other attacks that are aimed at stealing information without letting the site being hacked being aware and then selling it off somewhere. All kinds of this class of attacks. how aware is the security community to it, and is anything being done to help stop it?
So I think we should look at three aspects, three perspectives. First is programmers. So I think that awareness at the programmers level is very low. When I tend to explain what we do at Scribe Security to friends who are techies, many times it surprises them the ideas of how in general, how such attacks can take place. So I think that awareness at programmers is not very high, even though it is, I think, increasing. When you look at the security community, so there's a large difference between understanding and anticipating this fascinating attack that Jossef described as. So the attacker usually has the advantage that he chooses the way of attack, and he will do something very original, very creative, and these things are very hard to anticipate. So such a specific attack, that's really hard, and I don't think that it's not the easy one to come up with this scenario, and especially not as if you're on the defense side. But when we look at the security community on the perspective of the regulators and the frameworks, then we see that they got the hunch of it even without anticipating this specific attack. So if we would look at the original SALSA specification, we would see the requirement of signed commits. We would see the requirement of pull request reviews. So sorrily, SALSA focused the version 1 of the standard only on the build step. So if you're now SALSA compliant, you would not be protected from this type of attack. But there are other frameworks too. If we look at the CNCF recommendation for supply chain, an old document from 2021, it also addresses token revocation and token and credentials management and pull request rules and signed commits. If we look at the new NIST 204 document, which it talks about approaches to protecting the supply chain, this type of requirements goes through the document, and it's clear that these things need to be done. So I think what we see is that the standards already provide the quite generic ways to defend against large families of attacks. And once these would be deployed, then many of the defenders would not need to consider and try to imagine such ingenious attacks.
One of the questions I asked Jossef earlier involved open source. He did not give, he just scared us, rightfully so. And I told you that I'm going to ask you the same question later. So, Danny, considering that most software products these days involve a lot of open source, how can we use open source with an easier heart? It would never be completely easy. It would never be completely safe. But how can we lower the risk and make it more acceptable to use open source in a way that is at least open to the potential problems of it?
Thank you. So first, I think what organizations need to understand that it is a risk, okay, and probably it's a risk that in many cases has to be taken. Like, you cannot be competitive if you decide to develop everything in your own hands and to ignore the open source community. That will not work. So in many cases there is no real alternative, and the alternative is somehow to manage the risk. I think that's the basic notion that Jossef talked about and showed that it's tough, which is to somehow evaluate the open source, is an approach that may become more doable. Like if we take the OpenSSF scorecard project, okay, this is a project, an OpenSSF project, which provides risk score to a huge number of open source packages. And it takes a combination of metrics. Some of them are very indicative to weird open source that you would not want to consume without really digging into it. Some of these metrics, are debatable, but of course, it's much better to take a package that has a high score on its OpenSSF score than just to randomly pick a package. And if you want to excel, you could also look into the scores and say, okay, I want a specific measure to have a high score. For example, one of the measures in the OpenSSF scorecard is no binaries as part of the code. Okay, when you go to GitHub and you download the repo, you expect to find source code, open source, not open binaries, which are, as a matter of fact, they're closed. Right? Usually, most of us do not read binaries. So choosing this rule is very indicative to something that is strange. Not that there are no open source packages that need binaries inside. There are such, but when you choose such, you need to do it, with open eyes, and make sure that you understand the risk you're taking. Another advantage to the OpenSSF scorecard is that it is related to the popularity of the packages, and the way they built their database is followed the graph structures that Jossef showed. Okay, they chose the most popular packages, and apparently a popular if a package is popular, it means that all its dependencies are also popular, because they were needed to consider to run the first one. So choosing package that has such a score is, I think it's a great step forward. But again, I understand that no one can be sure that consuming such a package will not bring in malicious code.
I mean, from an attacker's point of view, I'd like to add, if I'm putting myself in the shoes of an attacker, I would make sure the project will get a high score. So I would enable protected branches and signed commits and everything, and I'll also include my malicious code, hide it somewhere where it's not containing any binaries, but it's basically whatever language that project was reading in would be embedded with malicious code. It doesn't take much for attackers to do these days. You can just undetected malicious code by IEDRs, endpoint antiviruses, etc. It's very, very impactful regarding staying under the radar. And if you're like with malicious intentions, from straight from the source, I mean, if you're implying the best practices by great projects, OpenSSF projects like Scorecard, I mean, it would get you as the maker of these projects, contributor of this project, you can make sure that it can appear deceiving for any other developer. I think the problem is where it's not starting, it's not initiated at the source, as I demonstrated, like FISL credentials, NPM credentials were compromised. So I'm curious, like, what's your perspective on that approach? Like, if I'm writing, the source code and maintaining it on GitHub, but someone steals my credentials and publish directly to NPM, and it doesn't have any related versions, releases on GitHub, that's literally an anomaly. Just curious your perspective on
it. So I think I agree with you that a huge part of being protected goes back to access. And anyone using GitHub sees in the recent days the new banner, right? That beware, two-factor authentication is going to be enforced in early January don't get locked out. So we see that the vendors are taking a step forward. If we will take specific NPM environment, so a few months ago, it was announced the cooperation between Sixer project and NPM. Okay, in that case, you could verify the packages, and it's not only verifying that someone signed them, you could verify that the identity of this Faisal, he is the one signed on it. And stealing his credentials could be done, but again, if it's done through GitHub and already has 2FA, it gets harder. Not impossible yet, but it gets harder.
So overall, based on summing up both of your approaches, be scared, be very scared. Once you're scared, you're at least somewhat aware. You can never eliminate the risk completely, but the more aware you are, the better. And of course, looking at a scorecard that is comprised of several characteristics is much easier than manually checking 600 contributors and over 800 packages, which just seems just straight out impossible. So it's better than nothing. And considering that we all need to use open source, unless we want to be left far, far behind, it's better than nothing. But yeah, other ideas which I've heard speaking to other experts is to check the packages or the project once you included the new package, which might be suspect in a sandbox, to make sure there's no unusual behavior, nothing goes out or in where it shouldn't be. And you should also try and well, I would call it stimulate malicious code by trying to attack it or look directly at it, or trying to attack whatever project you're developing, so that by looking at it like an attacker would, you might see something that most of the developers in the normal course of their development wouldn't even look at, because they're so busy in adding new features and fixing bugs. So that those are just a couple of ideas.
Yeah,
I would also
chip in more to concepts that we I think are you could say mentioned before, but one is getting intelligence. Like in this case, Checkmarx found out this attack and have a blog post, and you can be aware. And the guardrails approach of having, once we see such an attack, deploy policies that at least protect against this family of attacks. So again, we can narrow the steps of the attacker and hopefully disturb him.
Yeah. We're almost out of time. So if there's anybody in our audience who would like to ask my two wonderful guests questions, now would be the time. And while we're waiting for questions, let me just add that the intriguing concepts which you've heard Danny talk about, like adding policies to your development process and to your build process, CI/CD, these are all part of the Scribe solution. So if you're interested in it, I'm not going to talk about it here because we don't have the time. And if you're interested, just go look it up. Scribe security, it's easy to find. If you have questions about anything that we spoke here, you can reach me directly. My email will be added to the description of this video once we upload it. So just write me. I'll write to you as soon as I can with any answers. If I don't have the answers, I'll just ask Jossef and or Danny, which are far greater experts than me. And if we don't have any other questions coming by soon, which doesn't appear to be, awesome. That means you were very, very clear. So thank you very much for joining us. And I would like to thank Danny and Jossef for taking the time to be with us and explain this interesting attack. And as a goodbye to all of you, be aware, look at what you're doing, and think before you hit that commit button. See you on our next webinar.
Thank you. Don't take code from strangers.